Good afternoon, my YouTube viewers. It's Crystal here. I'm just here because I wanted to do a code review on how to make a Perceptron from scratch using jacks. Basically, what a Perceptron is, it is the first part of a neural network that was created early on in the 20th century, but let's just see when it was made, since we're Perceptron. Wikipedia. So the Perceptron was made by McCulloch and Pitts, and it was called the McCulloch-Pitts neuron, and it was made in 1943 by Warren McCulloch and Walter Pitts, and it wasn't actually used until 1958. And Wikipedia goes into detail about the Perceptron if you want to know more about it. But what we're going to do is we're going to code a Perceptron in the JAX library. So the Perceptron is a neural network, the very first basic neural network, and it's designed similar to a neuron in a brain, because you've got the inputs, and then you've got the neuron, and then you've got the outputs. So another thing that we can do is you can look at the images, see if we can find an image here. So right over here, you've got the inputs, which is the dendrites in a human neuron, and then you've got the cell body, that's your neural network. You've got your axon, which is your out, and you've got your axon territories, which is your output. So what they did was they designed the Perceptron to be very close to the way a human brain operates. So that's interesting, isn't it? And it's the very first neural network. So what we'll do is, now that we know when a Perceptron was created, which was in 1943, and it wasn't actually implemented until 1958, and we know that a Perceptron is a neural network that's designed very similar to the neural network in a human brain, what we'll do is we'll talk about the code. So the thing is that I created this program in Google Colab, which is a free online Jupyter notebook. It's a great platform to use because it's free. It doesn't cost any money. If you accidentally delete or overwrite code due to the fact that Google Colab does not have an adequate undo function, you can go into the save changes, and when you go into the save changes, you might be able to get your code back, but it's no guarantee. I've had to go back and use the save changes a few days ago to try to get some code that I had accidentally overwritten. So after what we're going to do is, the data set we're going to use is going to be the Titanic data set. And the reason why is because I want to do these algorithms in a data set that's a little bit difficult. And the reason why I want to do it in a data set that's a little bit difficult is because if it'll work on a difficult data set, then it'll work on an easy data set. And the Titanic data set is a little bit difficult. So after we created our Jupyter notebook, we're going to import our libraries. In this instance, we imported pandas as PD to create the data frame and process the data. We've imported JAX, that's to create the model. We've imported jax.numpy as JNP, which works similar to NumPy, but not exactly like it. There are changes. There are things about JAX that don't work in NumPy. For example, JAX arrays are not mutable, and since the JAX arrays are not mutable, you have to work around doing things. Another thing is that sometimes when you're working with JAX, you'll get an error message saying it's not hashable, and you have to work around that as well. And then we're going to import train test split from sklearn, which provides our machine learning functionality. It splits our data set up into a training and testing data set. And we're going to import matplotlib.pyplot as PLT, which enables us to visualize our data. So after we have imported our libraries, we're going to load our data set. So we're going to data equals bd.readcsv, and I used the CSV file from a GitHub account because you can download files from GitHub. And then so we download our data. You've got an ID, a passenger class survived, sex, age, HB, and fare. So the survived tells you whether or not that person survived. So since this obviously, I think it came from a European, they had commas instead of full stops. So we have to replace the full stops with commas, or we have to replace the commas with full stops, really. So now everywhere there's a comma, we had to replace it with a full stop. And now what we're going to do is we're going to impute the missing values for the age. And so if it was an adult, then the median age was, I think, 28 or 29. If it was a child, the median age was 9. So anywhere you had a missing value, it asked you if it was a child or an adult, and depending upon whether it was a child or an adult, depended on what age got put into the age. So now we just checked. We're going to impute the missing values for fare. So what we did for fare, if there was a missing value in fare, we just used the most frequently used value, and that was your mode function. So now what we're going to do is we're going to convert the age and the fare to floats. So now you've got your age and your fare as floats. Now we're going to convert the age and the fare to integers, so that just rounds off the any digits after the decimal point. So it just became an integer, and it'll be easier to work with as an integer. So we're going to convert the age and the sex to a float by creating a dictionary for the sex dict and age dict. The sex dict was a female is 1, male is 0. The age dict is adult is 1, child is 0. And then so we replaced the strings with the data in the dictionaries, which were numbers. So now instead of words, you have numbers being either 0 or a 1, and the sex and the age. Now we're going to drop the ID. You don't need ID, and the reason why is because in pandas, every row of data is automatically indexed. Now I just thought it would be nice to give you a nice little visualization of what it is you're doing. This is the greens are the survived, and the reds are the perished. And so you've got a lot more reds than you do greens, because a lot more people perished then they did survive. But I just thought that would be nice visualization of the data that you're working with. Now what we're going to do is we're going to assign our dependent and our independent variables. So your dependent variable is y and it is survived. And then your independent variable is x and it's the data except for survived, which is dropped. And then we check our shape and you'll see that we have a 1309 examples. We check info, and on info you can see all of the features or columns are integers. So now what we're going to do is we're going to standardize x. And the thing about standardizing x is that in Jack's NumPy, arrays are not mutable, and because arrays are not mutable, you have to work around it. So mean equals jnp dot mean x dot values, std dv equals jnp dot std x dot values, and then we standardize the data set. X equals x minus mean over std dev. So you can see we've got the data set, and you see that it's all been converted to, I believe it's 0 is the middle, and so it's going to be either the negative or the positive deviation, standard deviation. And that's how we standardize our data. So now we're going to convert the x and y into Jack's arrays. So x equals jnp dot as array x, y equals jnp dot as array y. You print the shape, you still got 1309. And now we're going to split the data set using sklearn's train test split. And then now you've got on your train, you've got 1047 examples, and on your test you've got 262 examples. Now we set the key, although I don't think we're going to use it in this instance, but I just went ahead and kept it. Now we're going into the Perceptron, and in the Perceptron you've got 4 functions. You've got the init function, and what that does is that initializes the variables that are going to be used. You've got the fit function, which trains the data. You've got the predict function, which predicts the data, and then you've got the unit step func, which is part of the prediction and the fit. So it's used in the prediction function, and it's also used in the fit function. And so basically this is your model, and I have actually created a blog post on how to interpret the code, and what I will do is I will leave a link to the Medium publication in the description box down below so you can read it and learn how to interpret the code for the Perceptron. We also have a function called accuracy, which calculates the accuracy of the Perceptron of the model. And then now what we're going to do is we're going to use the Perceptron model equals Perceptron model.fit xtrain ytrain ybred equals model.predict xtest. And then you've got your ybred, you've got lots of ones and zeros. You've got your accuracy as 71%, which is not as high as other algorithms that I've used, but it is a good start. And then what we're going to do is we're going to compare the Perceptron that we've made from scratch with the Perceptron that is in sklearn. So from sklearn.linear model import Perceptron CLF equals, I made a mistake there. I made a mistake there. CLF. It's going to take a long time to run it, so I'm not going to run it in this video. And the reason why is because you just be sitting there for 15 minutes waiting for it to run. But obviously that's why the accuracy of the Perceptron was the same as it was with sklearn. So when I finish this code review, I'm going to rerun it and see if there's a change in the accuracy. But I can't do it in the video because it would just sit there churning away, and I can rerun it for you, but it's so you can see what it does, because JAX takes a long time to train. That's one thing about JAX that I will say. It takes a long time to train. And so, but I'll get you started on it, and then you can see for yourself how long it takes to actually do anything. See, it's going to do this. It's just going to turn away for a long time, minimum of 15 minutes. It's like Random Forest. When I was working on Random Forest, it turned away for about an hour. And this is going to turn away for a minimum of 15 minutes, maybe longer. And so there's no point just keeping the video up while you're watching it turn away. But that's another reason why I like doing these code reviews, because like whenever I do a code review, I can pick out a mistake that I have made and correct that mistake. So I'm going to go ahead and close this video. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And I would like to thank all of my subscribers for supporting my channel. I would like to thank everybody for watching my video. And I'm going to go ahead and close the video because I've been talking close to 20 minutes. And so we've been talking for a while. And I will leave a link to the Medium publication blog post that I wrote on Perceptrons, so you can read that if you would like to know a little bit more about the coding of a Perceptron.